Hello everyone, welcome to our regular session focused on design and analysis and check of steel connections with the software IDEA StatiCa. This webinar is called Connection Wednesdays, as you already maybe mentioned, is regular, and today we will again my name is Jana, and my colleague Adam will present some nice example of steel connection in step-by-step procedure, and then we will see one issue from the customer. Before we start the session, let me just mention some practical things. You can communicate with us via the questions panel. You are muted by default for the practical reasons, but we will try to answer all your questions along the webinar, and those questions that will not be answered will be answered via email afterwards. Connection Wednesdays is a regular webinar. It will last about 30 minutes, maybe a little bit less, maybe a little bit more. And we are broadcasting twice a day. The first session is at 9 a.m. and the afternoon, or the second session, is at 4 p.m. in Greenwich Mean Time. So it means that it differs for your time zone. It goes every other week, and the last Connection Wednesday will be on December the 13th, 2017. So you will see today one customer project. It will be joined from welded square hollow sections, and you will see how to model it step by step. And in the end, in the rest of the time, we will have a look how the forces in anchors are calculated. Afterwards, we will have a little time for your questions if there are any. Now, let me pass the presenter to Adam, who will show you the first example.
All right. Hello, everyone. Hope you're in a good autumn mood, and we'll go through this example of welded SHS joint from one of our Czech customers. He used that in one steel hall and send us this interesting project into our library. So I'll start with the blank project. Just click new and select some of the topology to start with. So I'll pick this one and modify it a little bit. So okay, I will first delete these two members, D1 and D2, because I don't want them there. Okay, and then I modify the cross sections. So let's pick the SHS, and here it will be the RQ 200 by 12.5. Okay, here I modified the length, so I would have enough for the whole connection that I will model in a minute. And I set the same cross section to the column member D3 and modify its length again, 800. Okay, now these connected members here in the horizontal plane, change the cross section SHS and pick the QRO 100 by 8. Okay, and again modify the length 600. Now I choose the same for the rest, H3 as well. Okay, so that's the basic geometrical setup. Good. So the second step out of 3, as we know, is the load effects. And here we can fill that in a table or the way I like, because I'm sometimes lazy to import from the Excel. So I just copy those forces that I have calculated in some structure model before, and I import them here by clicking import. Control V as paste, and OK. So I have my forces here. I can check them in the 3D window. OK, this is looking as I wish to. Good. Fine, second step done, and we continue with the third step, and that's the modeling. So here I will start with the first modeling operation, and that will be a cut. So I will first cut the member H1 here by the CH, that's the horizontal beam, and I'll select the cutting method surface and change the thickness of welds to 5 millimeters. Okay, now I will cut the same member by those 2 diagonals here. So for that, I will just copy the operation here and change the CH to H2. Okay, so I added a cut here, and I will do the same for the H3 as well. Okay, we can see in the transparent mode how this is cut. Okay, like this. Good. So now continue with cutting the diagonals. So I'll cut select the new cut operation and select H2, and I will cut by CH, and again just modify the thickness of the weld like this. Okay, and I just copy the operation for the H3 member because it's all the same and it saves me some time. This is really nice feature. I like to copy the operation, saves me some time. I use it a lot. And now the last cut would be the column member. So D3 by CH, and modify the thickness of weld to 8 millimeters. And that's it. Okay, so we connected all the members, and now we will make this joint some more stiffer by adding a, how would I say, triangular boxes that we would prepare in the workshop before. So they will be butt welded. So let's start with them. A new operation and a rip, this one. Okay, so those will be connected to D3 and related to CH. Thickness of that rip would be 10 millimeters, a size 300 to 300. Okay, we have some here already, and I'll modify them. Triangular, this is what I'm looking for. Cross-section part, that will be set for the web 3. Okay, because this is the web 3. I want it here first. I will repeat by 0 because I want just 2 of them here. And I will locate them just on the front side. Here, just the lower surface. That's the surface of this plate of the member D3. Lower means this one, upper means from the other side here. You can just take a look. Okay, it goes through now the member. So the lower one. And the last thing, the thickness of welds and the position of them on this side. Okay. So that's for the ribs, and I will model, let's say, a lid here. For that, we will use a stiffening plate operation and modify this. So I'll modify the size 0, 120. So now the plate is somewhere here. You can see it here, and we will change its position. Origin set to a plate, and I will set it to this rib. 1A, that's this one. And I will change the position or the location from front to rear. Okay, so I move it like this, and also modify position in space like this, and rotate, and we have a lid here. And as I said, this will be done in the workshop, so I'll use butt welds, and this will be then welded on site to those two beams. Okay, so this is now looking like this, and we want to design this a little bit more. So I use operation cut of plates. So I'll be cutting the lid plate here, and for that I will just select here a plate, the SP1 of the lid. Okay, remaining part plus, and I will cut by the rib 1B, which is this one. Okay, so it's now cut, but I want it on the other side, so I'll select the minus part, and again the butt weld. Okay, that's good. So we've just modeled this stiffening triangular box, and we will now connect it also with those member plates of CH and D3. And I will do this again with the cut of plate operation. So now I will say I want to cut SP1, and I want to cut by a plate of member CH, and this is the web 3. Okay, and remaining part minus. Good. We have also the weld generated there. So I'll just change the thickness to 5 millimeters. And that's it. And now I will just copy this operation and set it for D3. Okay, so I again save my time and have it there. Good. And now we do the same for the other side. So now I'll really use the copy function that I love. So I will first I will copy the rib. So this will be now on the web 1. Okay, and just change the position of welds. This side, fine. Now SP, stiffening plate, again copy, rib 2A, and it's there. And I will also copy these operations and just change from SP1 to SP2, which is the lid on this side. Okay, and rib 2B. Okay, PCAT 2, copy, SP2, done. PCAT3, copy, SP2, D3, and this is now web 1 of D3, so I just changed it here, and that's done. So as you can see, the copy function, you can really have some nice progress with that. And okay, we're done with that. We move to check, calculate this, and see what happens. Let the iteration process run. We have just one load effect. So this is pretty quick. And here we can read the results. First, the overall view, the traffic light view or display as we call it, gray, green, orange, and red colors. Everything what's not red is fine. We have nothing red here, so that's really fine. We've passed the checks. This is well designed. What is orange is close to the limit, but still, according to the code, below the limit with all the safety factors included. So this is, let's say, very good design, closing to the limit. We can see if I choose, for example, this weld, let's highlight this, and this is 98% of utilization of this weld. So this is really economical design, well-designed joint. Okay, so then you can, of course, look at the equivalent stress and other displays here in the joint, about the plastic strain, turn on the mesh and see the deformation. Okay, this is bending pretty nicely from the moment here. So this is now quite stiff because we added these triangular boxes. So we can see how nicely it is working actually. Good, and the very last step is that you want to present your results. So you go to the report and print it out here like this, save it and edit it in a word processor or print out into PDF. You can also edit the report in the new version 8.2, which is now available to download from our website. We added more functions here to edit the report, so it's much more open, much more editable. Okay, I think that would be all from my side, and I'm switching back to Jana. And thank you for spending time with me.
Okay, thank you, Adam, for the example. And now we have time for one of the project that has been sent to our help desk. It's an example of anchoring to a concrete block. The anchor is made by, or anchoring is made by 4 anchors, and the customer asked about the resulting forces in the anchors. So as we can see, there is a bending moment about 37 kilonewton meters. So according to a hand calculation, if I have just taken a photo of really basic hand calculation. So from the 37 kilonewton meter, the base plate or the distance between anchors is half meter. So there should be 74 kilonewtons in 2 bolts which means the 37 kilonewtons in one bolt. So this was the expected value of the hand calculation. But if we run the calculation in IDEA StatiCa and we look at the results, I can display the equivalent stress and also the bolt forces here. And you can see that IDEA StatiCa shows that the force, the tensile force in anchors is about 50 kilonewtons. And this was the question of the customer: how is this possible that it differs from the hand calculation? So maybe it's for some of you, it may be like easy question, but it's important that it's clear. The answer is clear. So actually, the model in the IDEA StatiCa connection is the finite element model, and it takes into account the stiffness of all the members and all the plates of the connection, which means that it deforms due to the loading, and you can see that also the base plate deforms. Due to this deformation, there is some prying action in the anchors, and this increases the tensile force. So we can also demonstrate this effect if we make the base plate stiffer, so it does not deform so much. Now the base plate, if I go back to design, the base plate is about 20 millimeters. You can see it down here if I point on the base plate. So we can just make it thicker, let's say 50 millimeters. Okay, it's thicker now, and we recalculate. We go to the check, and we will display. Okay, and you can see that the deformation is much lower, and also the tensile force in the anchors is much lower. It's about 38 kilonewtons, which is very close to the hand calculated value. So just to be sure, if I click on the bolt, I can open all the formulas from the code we have chosen. In our case, it was Eurocode, so you can see that the anchors are checked according to Eurocode. You can see all the formulas with the values here, and also in the end, the utilization in shear and interaction of tension and shear. Okay, so I would say I hope this is clear, and we have also this issue in a document which is placed in our resource center. It's called it's in our FAQs. So if you go to our webpage, IDEA StatiCa, and I click on resources, I open steel section. So in our FAQs, there is a question why there are it's not this one. Why do I get high bolt forces in end or base plate? So this effect is of course also in end plates. Okay, so that's all from the customer issue, and I can have a look if we have any questions. Okay, there are not many, but there is one. So somebody asks, I have heard that there have been implemented slotted holes in the version 8.2. Can you show it, please? Yes, that's right. That's correct. So the new version of IDEA StatiCa has been released, I think, last week, and there are some new features, new very useful features. So for example, whenever there are some bolts, you can choose between normal circular holes and slotted holes. And it's really easy and fast to show. I will go to design, and in the base plate I can open the editor, the bolt, and here you can see that you can choose different shapes, so the circular ones and slotted in one direction or in the other direction. And I can also choose which bolt will have this slotted hole, so it does not have to be chosen for all bolts. And this is a nice feature because you can play around with the shear transfer in the connection. So if you for example design some shear iron in the connection, then you can place your bolt into slotted holes and all the shear will be transferred by the shear member. So yeah, actually I can show it now as well. So if I apply those slotted holes and cancel the editor, it should be here now. If I open the transparent view, yeah, you can see it. I will just check. Yeah, okay, so I can see the shear force in this direction and the bolts are in slotted holes. So now you have a possibility to place some member that will carry the shear, and I can choose the shear iron here. So you can see it's also a new feature for in our anchoring. So now there's some shear iron. It's you can of course choose any cross section from the library. Okay, I will just leave what it was there, and I can calculate. Okay, I don't know what results will I get, but all the shear now will be transferred with the shear iron. Yeah, okay, so if I go to the check, you can see that anchors do not transfer any shear force, and the shear is transferred by the shear member. So maybe this will be useful for some of you. Okay. Is there another question? Okay, IDEA StatiCa checks directly the results. Yeah, I don't know if I understand this question correct, but
I think it's a question if the IDEA StatiCa checks the results of welding according to Eurocode 3.
Yeah, that's yeah. If you open the welds, so all the formulas that I have shown before for bolts are also presented for all welds. So you can see that is checked according to Eurocode, and you can also print all these formulas in the report afterwards. Okay, so
and maybe you can also find this in the. I can show you this. You can find it in the report. If you scroll down here at the code settings, you can see all the references of the referent codes that I used for checking. But this is just we use the standard procedure for that. So I'm not sure, to be honest, what's Eurocode 3 if it's the right one, but we use the right one.
Okay, so there are no other questions. So thank you for your time. We are really happy that I will take presenter back. just for a little while. So we are really happy that we can see so many people interested in these webinars. Please come to our next webinar, which will be just in 14 days. The next one will be on the 1st of November, and you can also watch the recording of the webinar or send it to somebody. You can also visit our resource center, where you can find many tutorials, many information about the software. And we ask you to fill a very short survey after a webinar. It's about, I don't know, 30 seconds, not more. And for those of you who are interested in getting a trial version, please go to our, or you can just check it in the short survey, and we will send a trial version for you. Okay, so that's really all. Thank you very much, and hope to see you soon again. Goodbye.
Thank you, and have a nice rest of the day and enjoy your lunch. Bye-bye.